companies introduce new models of chips, what you're going to find is there's a code name associated with those, and the code name tends to stick to the chip all the way through its life cycle. And so there was not just this classic Athlon chip, there was also a Thunderbird model that had a PGA style. So you'll see these odd names pop up. This one happened to run, the AMD Athlon ran from 500 megahertz all the way up to 2.33 gigahertz in its Thunderbird models. It had a very interesting caching style that increased performance, and it had an enhanced version of the instruction set for graphics. Its 3D now was improved to handle even higher end graphics. The AMD Duron was introduced right after that not only introduced new speeds, but it had some real changes with the way the caching was done. And that's because it introduced higher performance. It had higher speed processors. And what was interesting about this is it had a smaller L2 cache, but it increased the size of the L1 cache. And that's because these processors were just so fast and were performing so well, they needed a larger L1 cache. What was interesting about this line, though, is you could take out a slower AMD Duron and introduce a higher speed version of it, and it used exactly the same speed of front side bus, which made it very upgradable. This was a very big competitive advantage that AMD had, is you could go from 600 megahertz almost all the way up to 1.8 gigahertz without changing your motherboard. You could essentially take a CPU chip out and put in a new chip. Now obviously there are some advantages and disadvantages to doing that, but the upgradability in itself with just the CPU was a big advantage that AMD had with this Duron line. The Pentium 4 came out right after that in about the year 2000. It definitely is PGA, and I put a number of the different models of Pentium 4 here, these different code names of Willamette and Prescott and Cedar Mill. You're going to see those names written down with the Pentium 4 because there were so many different models of the P4 that came out. It ran from 1.3 gigahertz through 3.8 gigahertz, and it had a redesigned architecture that was named NetBurst. What that allowed it to do is have an extremely deep and very wide pipeline. So it was able to send instructions through the CPU at a very high rate of speed. Combined with that, it had increased clock speed. So not only were you passing more instructions through the CPU, you were doing a lot more of them at the same time. So that having that architecture available really extended the capabilities of our processing power, and that was a pretty good reason why so many different models of the Pentium 4 came out. That particular style of chip and the architecture had a great deal of longevity. Competing with that was the AMD Athlon XP, and this XP had these different code names: Palomino, Thoroughbred, Barton, Thornton. The AMD Athlon XP was also had that upgradability aspect to it that the Duron had. What you also see here is AMD also increased the bus speeds along with Intel at the same time. There was quite a bit of fighting now going on, very competitive in these two markets during this time frame. What was interesting about the XP is it had a lower voltage requirement, which allowed them to work in different motherboards, definitely smaller motherboards with smaller environments, even in laptop environments as well. So having that lower voltage extended the capabilities of the processor through many different types of systems, not just server and desktop, but also the laptop systems. Intel introduced something called the Xeon processor, and it really did that back in the P2 and P3 days, but this is really where they caught stride. It was about the 2001 time frame. This is a high-end processor line. We talked about the Intel Celeron as being the value line. We know that the Intel Xeon, even to this day, is considered the high-end processor line. So if you have a file server, an application server, a server that's performing a lot of functions and handling information for a lot of people, you'll see a number of these processors like the 3000 series, the 5000 series. This is about the time frame where you start to see the departure of the processing clock speeds, and you see more of these model names associated with this. This particular processor was really designed for systems that had multiple CPUs in it. So if you had a server that had a dual or quad processor system, these were the types of processors you'd put into those servers to get the maximum amount of performance out of them. It was in 2001 where we really started to see 64-bit CPUs really come of age, and the Intel brand of Itanium refers to Intel's line of 64-bit, a high-end line of 64-bit CPUs. The Itanium, when it came out, used this PGA cartridge, a pin array cartridge. which if you look at the bottom looks very similar to a PGA chip, but you can see it's on a little bit longer platform. So it's a little bit different than the style that was there in the past. What was different about this very high-end 64-bit chip is it used these features called branch predication, speculative execution, and branch prediction. Now, branch predication and speculative execution were used as instructions came through. The chip would decide how many different ways you could go with making a particular transaction. And before it got the last piece of information, it had already determined what all of the different outcomes might be. And when it finally got the last piece of information, it had already calculated the piece out and could continue on its way. All of those other calculations that were done that it didn't follow, it just threw them away. And that's the speculative execution piece of this. It just threw away the things that it didn't need. The other piece that was interesting was this branch prediction. The chip had built into the hardware a way that it could predict which way most of the time you'd be going with a particular function, and it calculated those first, so that when you finally got that piece of information, it was assured that most of the time it knew the direction you were going to go, and it could have already predicted that piece, and again, throwing away the things that it didn't need after the fact. This was a very different way of looking at processing power inside a CPU. So obviously the 64-bit arena was one that was extremely competitive and demanded a lot of performance from these chips. AMD also introduced a 64-bit processor called the Opteron, and that was the brand that they assigned to their 64-bit line of CPUs. You can see the micro PGA was the style used for this particular chip. There were a number of different models introduced for this, a dual core, a quad core model. But what was interesting about this chip is as AMD moved from into this 64-bit world, they created a chip that very efficiently would also execute 32-bit applications. This was really important as the industry's been making this transition from 32-bit to 64-bit, that the CPUs would be able to do this. At this point, Intel's technology couldn't do this at very high speeds. There was a speed problem that they had associated with it. It had to slow down to perform 32-bit calculations. AMD's chip, the Opteron, did not. So this positioned them very well in this world. And it natively executed 64-bit applications at the same time. So a very powerful chip from AMD's perspective. Today, the latest generation of CPUs is really positioned well for both AMD and for Intel. AMD has a number of high-end server and workstation lines that they continue to sell with that Opteron brand we were just talking about on the 64-bit side. On the workstation side, there's a quad-core line called Phenom. The Athlon continues to be a powerful brand for them with their dual-core, quad-core, 32-bit, 64-bit. It is the workhorse of AMD and what they're doing today. And there's the Sempron line that is that value line. It's the everyday computing you might see from AMD that has a nice price point associated with it. On the mobile side, laptops tend to use a line from AMD called the Turon. And if you see that, it's usually a lower voltage CPU that's going to run very cool inside the laptop performing systems. Intel has also similar lines available that they're offering. On this Celeron continues to be a very strong brand name, and that's the one people think about when they think about that value line of processors. On the workstation side, we continue to see Pentium, but these days that Intel Core line, especially the Core Duo and the Core 2 line, is extremely popular. And the Centrino line is also one that we'll see a lot in mobile technologies that brings a number of those architectures into the lower voltages that you need in a laptop environment. On the server line, you continue to see the Xeons, especially the multiprocessor, and the Itanium for the high-end 64-bit processing that you need on a server environment. In review, we have gone through very quickly a history of what's happened in the industry with Intel and with AMD. We've not only seen where we've come from a 32-bit perspective, but we've also seen what's happening today with our 64-bit line of processors and where they're going. And the latest generation continues to build on that with multiple cores and different platforms and architectures for laptop and for value line CPUs as well. To comment on this video or to watch any of our free A+ videos, to participate in our message boards, or maybe add something to our study guide wiki, feel free to visit our website at freeaplus.com.